Good morning, and it's so great to be here. It's so great to be in the midst of people, to be out and about, to see colleagues, friends that I haven't seen for a long time. Of course, it's tough. You see this mask, all you see is two eyes, and I got to figure out. I've been doing pretty good, though. It's not easy. So I've got a lot to say. I was just making a comment to Tom Stamey from Puget Sound Naval Shipyard on, I think we're going on our 12th year of CSAT, which is amazing. And every year we've grown considerably. I think the first year, I think we're just shy of like 100 people. And last year we're just shy of 800 people. So it's amazing. And every year I think, geez, what am I going to talk about next year? We've made such advancements in this area and that area. And this year, it's just amazing at the amount of progress, the accelerated transition and implementation, the number of systems, okay? I've contacted a number of the major equipment suppliers for cold spray, the center lines, the VRC, Speed 3D, Impact. Years ago, when I first started, geez, in the late 90s, and Keith Kowalski knows, I mean, he was one of the pioneers way back when, working with Dr. Anatoly on the first systems, with a K-Tech system. Remember, I bought the first commercial system. There was a system at Sandia Labs as well, and we could count the number of systems on our hands. I talked to Julio, and he told me there's 150 center lines out there. Right, and talk to Impact and CGT. Between the two, there's 120. BRC, there's 40. Speed 3D is about half of that in about half the amount of time. So I've got a lot to say. So with that, I welcome everybody. And we all know what CSAT is, right? It is not a formal, stuffed shirt conference. We're here to discuss, to debate, to go over, high points, low points, and to push forward the technology throughout the world. I want to make CSAT more international, and you'll see on the agenda, we're making an effort to do that. So if I can figure this out next. Okay. All right, State of the Union address, right? So I pulled this picture. It's Woodrow Wilson's State of the Union address in 1915. And prior to then, there were only two State of the Union addresses by George Washington and John Adams. Everybody else just basically put it in written form, which is interesting because, we have State of the Union addresses now. And so there are topic areas that I want to hit upon. I actually removed one. Manufacturing at the point of need, that's our theme. 3D printing, that is the future, big time. We advanced from non-structural repairs to structural repairs to doing some AM parts, but 3D printing is going to be the future, as well as structural repair. And that's where we're most definitely headed. You'll hear talks today from VRC, introducing their upcoming software about this time next year, probably. They'll get into it. You'll hear talks from Speed 3D, which is already there. You'll hear about their collaborations. It's pretty fascinating. And manufacturing at the point of need, what does that mean? It's just what it says. So if I'm out in the middle of Afghanistan, out in the desert, and I need to be able to repair or make parts, I need to be able to do so. So that's manufacturing at the point of need. Cold spray feedstock powders. I'm gonna be telling a couple of stories about the importance of powders. There's no doubt about it that one of the attributes of cold spray is what? Being able to take commercially available, off-the-shelf thermal spray powders. You can do that, but you're gonna get to a point when you want to entertain structural repair, you want to entertain additive manufactured 3D printed parts without a lot of post-processing, Garbage in, garbage out, the old computer adage. So I'm going to spend some time this morning. Helium recovery. Yeah, that's interesting, right? So we know a couple of things. We know in Europe, helium is, a no-no, right? It's hard to get. It's very expensive. Not that it's cheap here, but at least we can get it. It's from natural gas reserves, and we just tapped into the, as kids, we were told that we're going to run out of oil and gas. All right. Well, we've tapped into the largest reserves known to man. Okay. Well, helium is a byproduct. So we're able to capture it in the United States, but it's still, you can view it as a finite commodity. It is expensive, 100 times more expensive than using nitrogen, but it's got big attributes, right? You get the highest velocities from using helium. So there's big efforts in trying to come up with helium-like properties using air and nitrogen, but there's helium recovery too. And I've got a few slides on that. So to jump right in, the Cold Spray ecosystem. Creating that over 22 years. And I would say 90% of the people are tapped into that Cold Spray ecosystem that are sitting here today, either directly or indirectly. What is he talking about, ecosystem? Ecosystem consists of numerous universities, national laboratories, industry players, Department of Defense, energy, other research laboratories, I still refer to it as United Technologies Research Center, so it's Raytheon Technology Center. But lots of projects, programs that 1 year, that ecosystem sustained in upwards of $120 million, okay? And part of what you're here to do is to be networking, forming partnerships, future collaborations, taking what I say and a lot of these great speakers you're going to hear today and say, geez, wow, I didn't know you could do that. Or look at, geez, look at what they're doing here. We should be doing that. And then finding out the people to work with to make that happen. I'm not going to go into these areas. You can read just as well as I can. But there's basic research opportunities. There's testing and qualification, there's certification, there's transition, there's implementation, there's the development and sales of feedstock powders, of equipment, of additional hardware, software, accessories, support equipment, etc. That's the ecosystem. And it is not a closed system, it's an open system. We try to make it be as much open as we can. We know Cold Spray. I've developed personally with my team through the years, applications and transition into all these areas. Oil and gas, automotive, especially aerospace, right? I mean, that's basically the first industry that I targeted. But there's others, including medical, antimicrobial coatings you hear. And it's so funny because the work that I did with the team, geez, 2008 to 2010, published some papers, in like 12, 13, basically touting the benefits of antimicrobial coatings. So people are crawling out of the woodwork now. If they would have implemented stuff that I had said 10 years ago, we would have been much better off. So there's a lot of visionary statements that I make through the years, that other people make, presentations that you will hear today, and 5, 10 years from now, you'll be saying, geez, I heard that first at CSAT. And so with that, I'm going to throw up this slide. So part of what I've been doing is to substantiate some investments with folks that I work with, market studies. This just happened. You could pull this off the internet. All right, that's where I pulled it off. But it shows the tremendous upward trend. And a lot of these areas, I'm looking at Aaron Nardi through the years that we've developed. All right, we've developed and impacted a lot of these areas. So you see the significant rise. Now, I think in dollars, we're still about just shy of $2 billion, where thermal spray, I think Keith is what, are upwards of like $8 billion. And I firmly believe that we should be in upwards of that number. And with the advent of 3D printing, I think we should be surpassing that. I think that's what the future holds. I pulled this to show the importance of additive manufacturing. I'm going to tie it into manufacturing at the point of need and 3D printing. But this is a DoD mandate. And again, you can pull this off the internet. That's where I got it. You see the distribution statement. You see the website where I pulled it from. And this is a directive coming from, DoD on the benefits, the attributes, and the go-forward plan. We need more lethal systems powered by innovation designs, kind of a general statement. It increases material readiness, empowers warfighters to solve problems in the theater, right? We don't have to rely on a depot. We don't have to rely on a repair station in theater. But depends on, hey, how far advanced are we? Are we mature enough? Level of expertise, training, certification. You can buy a system, doesn't mean you know how to use it, right? And then finally, data. When I first started the ESTCP program, which serves as the poster child for qualification of non-structural repair, is the one document right now that contains the most data on any one single material substrate combination. That's how I'll say it. And that's all going to contribute to how far we get. All right, I'm going to show you a couple of 2-3 examples, highlights, again, over the last year or two. I wish Fred Lancaster were here, because I mean, this is where he could bathe in the limelight. So this is a news press release on the VRC system, mobile system, repairing a windowsill area on the V-22. So it's basically, it's a mobile system. You see, it's attached to a robot. It can be manipulated out in the theater, out on a tarmac, wherever you need. And here's a quote from Fred. The future is with structural repair. And I'm going to go so far to say he's absolutely right and go beyond that. Structural repair and 3D printing. I'm going to give you another example of a different system. This is amazing too. And I just heard that this August, the Aussies and the US Marines are going to be doing joint maneuvers out in Australia, out in the outback. And they're going to be taking a number of these systems out there and not only producing parts, because they've done this, I think 2 or 3, I think this will be the 3rd time together. And actually I heard about it, I'm looking at Aaron, because we had to do a tour for a general who basically said, hey, can you do this? I just came back and we were maneuvers with the Australians and they're doing this. And so you see basically a Speed 3D unit, instead of that bright fire engine red, is camouflage, right? Because that wouldn't go over well in the theater. You'd be a target. But they're making parts. And not only that, they are going to be inserting and testing those parts in theater over, I think, a 2-week period. So that's pretty neat. All right, these 2 good-looking guys, right? This is over the last year. All right, and here's my quote. All right, and I've said this since day one. It's not just a coating technology. It's not just for repair. The future is going to be, and so in 3D printing. So that was printed like last August, July. This thing has a delay. Here's a near net shaped part. Was produced a couple years ago, 2018, introduced into the Patriot missile. The future of cold spray systems. I just want to, and I'm going to end with this too. When we, at the end notes on the second day, I'm going to end and go into this in more detail. But what I see in the future perfect system, and I had said this when I was the keynote speaker at the 2007 International Cold Spray Conference, the 2011, and I'm going to say it today in a different note. The future system, it's got to be flexible. What does he mean by that? And it's got to be adaptable. Flexible, adaptable. I want that future system to be able to do high pressure, to be able to do low pressure, to be able to have software and hardware to do 3D printing. I want that system to be modular in concept, but at the same time be turnkey. I want that system to be able to fit in a manhole cover in a submarine, because of its modular concept, being able to be taken apart and put back together again. Or I want it in a production setting or out in the middle of the desert or anywhere else. I want it to be repeatable. That's not just me, all right? Whole additive manufacturing industry, it's got to be repeatable. You've got to get repeatable results. They got to be reliable results too, all right? Am I hitting the requirements, the specifications? Got to be robust, all right? I don't want to take some laboratory system out in the middle of a desert and it falling apart because you know, some dust infiltrated it, or I take it out in Alaska and you know, a pump freezes up because you know, it's not made to withstand cold weather. And I want it turnkey. And I don't want to be saying, you know, you got to buy this, you got to buy that. Well, we don't do this. No, turnkey. Okay. Tell you a little story. Not all powders are created equal. All right. And I've got a lot to say, and I got to blow through these slides, but it's important. And I don't want people using that argument against me by saying, oh, look, you're going to buy special powders in order to use this system or that system. Oh, I don't want that. I want to be able to use off the shelf. And that's fine. Number one, you can buy these powders off the shelf that are made specific. All right. But number two, if you're doing a bubble gum repair, and I call the bubble gum repairs what? You're using BHOD, you're using epoxy repair. You got a ding in something, you put a little epoxy. I don't care what kind of powder you use, and it doesn't really matter a whole hell of a lot. But when you go to structural repair, when you go to making a 3D printed part and you don't want to post-process, heat treat, anneal, you don't put any work into your feedstock powders, garbage in, garbage out. Actually, I stole my own thunder, right? This thing has a delay, it's ticking me off. You have to actually press it a couple of times for it to do once. But anyway, this is aluminum powder, okay? So to the uneducated, I'm buying some aluminum powder, just give me the number and I'll call. You could get any one of these for aluminum powder. They all meet the chemistry. They'll all meet the past requirements for aluminum powder. I wouldn't meet it now because we've got flowability, we worked into the specification and other things, so you couldn't get all four of these. But a lot of people, they don't know the difference. This, and this. Totally different. You don't want all ping pong balls. You don't want cornflakes. Think about how they tumble in the gas stream and when they impact or the deposit is going to look like Swiss cheese. Agglomerate, pieces of coil stuck together. Deposit efficiency is going to go down the crapper on that, using that powder. This isn't bad. You got some block, but I see some vesicular in there. I see some big old boys. You want aggregates. And that's just geometry. Did a little experiment. So a guy did his PhD thesis on this that I know. And what he did is he took as received powder, he exposed it to humidity. And what I mean, oh, they can't hear me online? Okay, all right. So you got to have one of these walking things. I got a little animated here. You got to you got to chain me to this damn thing. So I can't see the slide. Actually, I wonder if this helps. No, that's worse. So anyway, We wanted to expose it to humidity, all right? And I fought with people, all right, from, well, I won't say from where, from DOD, who told me that aluminum powder doesn't further oxidize, doesn't form you know, when you get it in a gas atomized condition, it's not going to grow any more oxide. That's a bunch of crap, all right? And as a matter of fact, I got in a further slide, you know what they use aluminum powder for? Is a desiccant. What's a desiccant? Something you use to absorb water. Hello? How does it absorb water? It's a chemical reaction that takes place, all right? And you form hydroxides. Well, picture yourself at Corpus Christi Army Depot in the summer. Got a bucket of powder that you buy. Because you don't buy, you know, typically they don't buy powder just for one spray trial or one spray run. No, they'll buy a bucket. They'll open that bucket up, put in what they need, and then leave the bucket open. And if you're lucky, they may close it. Doesn't matter. The experiment, we opened up the bucket, closed it, opened it up to simulate, you know, like a couple, 2-3 weeks of doing that. And then we characterized those exposed powders and we compared it to a baseline. Then we did single particle impact studies to see how it would impact the critical velocity required to have the particles stick and consolidate, all right? And then we made blocks of material and we did all sorts of mechanical tests on it. We even did conductivity, did hardness, did UTS. And guess what? I've already said this. Yeah, I'm going to point this out again. For those that don't know, aluminum powder is a desiccant. And so for people that say, well, what test did you run? You know, you can read just as well as I did. I mean, we did everything under the sun to characterize the oxides, the hydroxides before and after. The most in-depth study that I've ever done, I bet you that anybody's ever done, that I've ever read by far. Look what happened to hydrogen. Look what happened to oxygen. Comparing it to the as received to the group that was exposed to 95% humidity. It went through the roof. You don't get hydrogen from the formation of an oxide. You get it from the formation of a hydroxide. So it hydrolyzed, that powder hydrolyzed. I'm not going to point out all these different samples. We did experiments in heat treating the powders, and you see the differences in ductility. But the point I'm trying to make, you open a bucket of powder, it gets exposed to humidity, it's going in a crapper pretty quick. And we've experienced that firsthand before we knew this, all right? We got properties in the as received powder that were great. We sprayed it a week later and it was garbage. You're doing bubblegum repairs, doesn't matter. You're going to structural, you're going to 3D printed parts. You don't have specialized feedstock powders, you're asking for trouble. Differences in fractography, you know, I don't want to be just a talking head about programmatic stuff. I love the technical stuff. Ductile dimpled, all right, in the as received, intergranular brittle fracture, and the high humidity. So what did that mean? You got a oxide, hydroxide formed on the outside side of that particle, all bombarded, formed a big block of material, bunch of oxide in there. You pull it, it's got no ductility whatsoever, and it fractures in a brittle fashion. You want that on an aircraft? I sure as hell don't. This is the process that we use now. We process the powder, we have preferred geometry, and I'm not going to go into all of the different QA tests that we do, but it's flowability, it's chemistry, it's geometry, it's particle size distribution, and it's packed inert. This is a fascinating study, and this was part of the PhD thesis. I had data which extended to a year at the time. Now we have data that extends out since 2017. I just did some averages and made that chart. But basically after 4 years, So think of a can of tuna. Whether you eat it on day one or you eat it 3 or 4 years from now, you're not going to get botulism and die. The cool thing about this is 4 years later, in that inert package, I can use the powder. So if I'm on an aircraft carrier out in the middle of the damn Pacific and it's humid as hell, that powder's protected and it's little cushy world in that inner environment saying, I don't feel the sea mist, I'm not hydrolyzing, I'm having a great time, I'm nice and dry. And if you get so inventive, which we have, you can develop a little nipple on this thing such that you've had a female and a male connector to your powder feeder. So even when you put it in a powder feeder, you don't even have to expose it for those few seconds or minutes, if your heart so desires, if you want to keep it to that level of control. And this is what happens. This is a single splat, a single particle. Now I got 5. So these brightened areas and this dark area here, I'm going away from the mic again, represent areas that are unbonded. And that's where the hydroxides and the oxides are. I made a little cartoon. All right, so don't think your AL powder has a nice little candy coating like an M&M of an aluminum oxide on it when it gets hydrolyzed, when you open it up at CSAT. No, it will hydrolyze immediately. Helium recovery, I want to end with. Don't think that you can't use helium. You can. There's an actual system. Actually, I want to go back. That was the concept of just having a turnkey helium recovery system that would be efficient within a short period of time. That short period of time, it differs depending on how much flow you have. I don't have time to explain the entire system. You can see me afterwards. We can discuss it afterwards. But it becomes efficient, I'll say between 20, 30, maybe 40 minutes, depending on the flow rate. So if you've got a 5-minute spray, a 10-minute spray, you're not using this system. But anything else, you do use that system. It's recovering anywhere between, 94, 95%. When it's fully in operation and you've got long sprays. That's kind of what it looks like. There's a little cartoon that I threw up, which is it's God's honest truth. When I was at ARL, and we were spending 800 grand a year. I mean, that's how many trailers we would have. With the helium recovery, if you were to use it, you'd see that those, 26 jumbo trailers would be reduced to like 1.5. This is my final slide. And yeah, I am proud of this. And we busted our hump putting this together. And I think it took us, I'm embarrassed to say, I think it was close to 4 years to put this thing together. You can buy it now. I think it came out this week. This is the first book, all right, that shows you from a practical perspective what cold spray is all about. You see the different chapters from setting up a system. This book has the most material properties. Oh, that's his book. He said, I don't get a dime for selling 1 or 1 billion copies. I work for Uncle Sam. I don't make a dime. I wish I did, because this is going to be a good book. Well, it is a good book. And you see the editors. I want to give credit to the editors. Ozon from Northeastern, Aaron Burt, Aaron Nardi. I'm looking at you, Aaron, because he's giving me, hey, you gotta finish, right? And so Aaron Nardi, I will say from ARL, he's with VRC now, but I was at ARL like 99% of the time when this was completed. But it talks from a practical perspective. So a guy in a depot, this would be beneficial to, but then also an academic would be beneficial, because it's got the theoretical explanation, but it's got the backbone of it is practicality. It's almost like a how-to book. You go to Home Depot, you want to put in your own sink, right? Your wife's on your case to put in your own sink. You don't want to hire a plumber. So you go out, and that's what this is. from setting up a system to qualifying a process, to transition, to implementation, to specifications and standards, and developing your own processes, to feedstock powders, to material properties, and what tests should you be conducting, what inspection criteria should I be using, the whole 9 yards. So I'm going to end with that and introduce the next speaker, who's my bro, who left me. I'm crying still. But it's Aaron Nardi. He's with VRC Metal Systems, and he's going to be giving you a talk this morning. It's always good to hear him speak. It's such a wealth of information. He's been in it for many years, you know, from a user perspective, from a hands-on perspective. So without any further ado, Aaron, I'll take the hook and I'll let you present.